Can AI predict our next pandemic? Are we really prepared? Imagine waking up one day to find out that a mysterious virus has started spreading on the other side of the world. That's exactly how the world met COVID-19. But what if I told you that this might have been predicted? That there's technology capable of detecting the early signs of a pandemic before it even happens? Yes, we're talking about artificial intelligence. But the big question is, can AI really predict our next pandemic? And even more important, Tar, we ready to trust it? In this video, we'll dive deep into the fascinating world where algorithms, data, science intersect in an attempt to stop the next global health crisis. Get ready, what you're about to discover could change how you see the future of humanity. What is artificial intelligence in healthcare? First, we need to understand what artificial intelligence actually is when applied to healthcare. AI isn't magic, nor is it a crystal ball. It's a technology based on algorithms capable of analyzing massive amounts of data, finding patterns, and making predictions. In medicine, AI is already used to diagnose diseases, forecast outbreaks, develop new drugs, and even assist in surgeries. But when it comes to predicting pandemics, the challenge becomes far more complex. It involves data from countless sources, medical records, climate patterns, animal behavior, and human movement. AI processes all of this to try to anticipate where and when a new pathogen might emerge. Sounds like science fiction, right? But it's real. It's a BlueDot case. The algorithm that spotted COVID before the world did in December 2019, before most health authorities even noticed. Canadian company called BlueDot detected an unusual outbreak of a respiratory illness in Wuhan, China. Its AI system scans real-time data from news reports, social media, flight records, and epidemiological databases. It issued an alert about the risk of a new pandemic days before the World Health Organization released its first public statement. The BlueDot case proves that AI can indeed detect patterns that humans simply cannot see as quickly. But if it's that efficient, why couldn't the world prevent COVID-19? The answer is far more complex than it seems. AI works in pandemic prediction. AI in pandemic prediction works much like a brain that never sleeps. It gathers enormous amounts of data from diverse sources. Hospital reports, academic publications, online news, population mobility, climate changes, and even social media posts. Then it uses predictive models like machine learning and deep learning to find correlations that humans would never detect in real time. For example, a sudden rise in cases of atypical pneumonia in a specific region, combined with international air traffic and changes in animal migration, might trigger an alert. But here's the big question. Are those data enough? And more importantly, who controls that information? The limits of data, the challenge of incomplete information, as powerful as AI is. It's limited by the quality and quantity of the data it receives. And this is one of the biggest challenges. Many countries don't share health data transparently. Others lack efficient data collection systems entirely. And then there are pieces of information that simply aren't recorded, like outbreaks in remote communities or conflict zones. Without reliable data, AI is blind. And contrary to what many believe, an algorithm isn't magic. It's only as good as the data feeding it. The role of animals and AI is watching most pandemics originate from zoonotic diseases transmitted from animals to humans. This was true for avian flu, Ebola, SARS, MERS, and possibly COVID-19. AI can be trained to monitor wildlife habitats, track migration changes in bats, birds, and other virus carriers, and even predict when deforestation might increase the risk of disease transmission. Companies and universities are already developing models that combine satellite imagery, biodiversity data, and climate change metrics to create risk maps for the emergence of new diseases. This is technology trying to understand and predict nature itself. AI and human mobility - viruses travel by plane. If COVID-19 taught us anything, it's that viruses now travel faster than ever, and AI knows this. Prediction platforms cross-analyze commercial flight data, international traffic, and migration flows to model how a disease might spread. What once took months can now cross continents in under 24 hours. This means that, besides predicting the emergence of a disease, AI can also simulate how it would spread worldwide. This kind of modeling is crucial for governments to decide when to close borders, issue alerts, or prepare their healthcare systems. Ethical dilemmas. Are we ready to trust AI? Now we step into dangerous territory? Imagine that AI detects a potential outbreak in a specific city or country. Who gets that alert? The local government? International organizations? The public? And what if it's a false alarm? What if it causes unnecessary panic, economic collapse, or even discrimination? The responsibility behind these decisions is enormous. There's also the issue of who controls this data. Big tech companies, governments, NGOs. We're talking about sensitive information that can impact billions of people. Using AI for pandemic prevention comes with deep ethical challenges surrounding privacy, sovereignty, and governance. The data, wars, governments, corporations, and hidden interests. The COVID-19 pandemic showed that in today's world, data is more valuable than oil. Tech companies, governments, and even criminal organizations know this. The race for health information is brutal. Some countries hide outbreaks to protect their economies, while others leverage data for geopolitical advantages. In this scenario, blindly trusting AI is risky. If the data is incomplete, biased, or manipulated, the predictions will be flawed. This raises an uncomfortable question. How can we trust machines if we can trust the humans feeding them the data? AI versus fake news. A silent battle. Another massive problem is the impact of misinformation. During COVID-19, we saw how fake news can spread even faster than the virus itself. It affects AI too. When algorithms are trained with contaminated data full of conspiracy theories, rumors, and false claims, their predictions become unreliable. That's why, besides predicting pandemics, AI must also filter and fight misinformation in real time. And believe it or not, that's just as difficult as forecasting a viral outbreak. The HealthMap case. Another AI raised the alarm. Besides BlueDot, another system stood out. HealthMap, developed by Boston Children's Hospital. This AI monitors public information like news reports, official statements, and even online forum discussions. HealthMap also detected signs of COVID-19 before it became a global crisis. This shows that it's not just one algorithm, but an entire growing ecosystem of AI tools working to monitor diseases. But then comes the big question. Why did we still fail to contain COVID-19? The answer likely lies in how slow governments are to act, how hesitant they are to trust alerts that come from machines. AI and vaccines, accelerating solutions, not just predictions beyond predicting. AI plays a crucial role in responding to pandemics. During the COVID-19 vaccine race, algorithms were used to map the virus genome, identify targets for immunization, and speed up clinical trials. The development of mRNA vaccines, like Pfizer's, was made possible at record speed, thanks to AI and machine learning. This means that in the future, we won't just be able to predict outbreaks, we'll also be able to rapidly develop vaccines and treatments before the problem escalates globally. The future of AI in public health? Dream or reality? Imagine a world where the slightest anomaly, a spike in Google searches for strange symptoms, or a sudden drop in a food item sold in a remote village triggers an AI alert to global health authorities. Interconnected systems working together to anticipate pandemics, initiate containment protocols, and even guide the development of preventive vaccines. Sounds like a distant dream? Actually, we're already taking the first steps toward that future. But this model's success depends on global collaboration, open access to data, and most importantly, trust between nations and their people. Future challenges? What could go wrong? Despite all these advances, let's not be naive. AI is not infallible. Models can fail, data can be corrupted, and systems can be hacked. There's also a real danger in becoming over-reliant on AI for critical decisions. What if AI gets it wrong? What if a false alarm leads to unnecessary border closures, financial collapse, or the isolation of entire communities? On the flip side, what if we ignore a real warning? The consequences could be catastrophic. That's why the future of pandemic prediction will always require a mix of AI, science, human collaboration, and inevitably a good dose of technological humility. Will AI save us? So back to the question that opened this video. Can AI predict our next pandemic? The short answer is yes, but not alone. AI has the power to be a game-changing tool in early outbreak detection, in modeling how diseases spread, and in rapidly developing solutions. But it depends on reliable data, international cooperation, and responsible human decision-making. At the end of the day, technology is just an extension of ourselves. If we want it to save us, we have to do our part. Share data, fight misinformation, and most importantly, learn from the mistakes of the past. Because the real question isn't if we'll have another pandemic, it's when.